Circles. We talked about circles way back when. Okay, I'm actually gonna set the radius here to 1. We talked about circles, gosh, first week, second week. It's pretty early on. It was like section 1.9, I think. We talked about circles. I won't expect you to remember too much from that lecture, but x squared plus y squared plus radius squared is a circle, and we're going to talk about a very particular circle here. So x squared plus y squared equals r squared. But we're going to have our radius set to 1, and what we're going to hopefully examine today is what's called the unit circle. That's the idea anyway. Okay. What is the unit circle? Well, this is our old friend, the Cartesian coordinate system, the usual one there. Let's look at some specific points. So we have a circle on the plane, and it's of radius 1. So this is at the point 1. This is y equals 1, -1, -1. So that's the circle that we're thinking about. Right? So that's the point 1, 0 there, or 0, 1, or -1, 0, or 0, -1. That's the circle we're thinking about. We're going to try to find a whole new language about angles. Okay. I'm going to have to just pull some formulas out of thin air, ones that we learned, I don't know, grade school, middle school, high school, but a few that we need. And one of them is, do you know what the fancy number pi is? Like 3.1415269, that guy. Do you remember where that comes from? Has something to do with the circumference, has something to do with diameter. Do you guys remember what pi was? You guys do the ratio of what? Is it circumference by diameter or diameter by circumference? Anybody remember what pi is? Yes, okay. All right. Let's start here. So the circumference of a circle is 2 times pi. Pi, in my opinion, is a magic number. We've talked about magic numbers before. One of them is E. E is kind of magic. Square root of 2 is a little bit less magic, but pi is definitely. Okay. In math, we call them transcendental numbers. Okay. They're almost outside of algebra. And pi is something that has to do with all circles. Okay. Not just this unit circle, but all circles have this ratio about them. So if it's a perfect circle, it has something to do with this ratio. Okay. Something very special. Okay. And the circumference of a circle is 2 times that number. Okay. So what is the circumference? I shouldn't assume anything. So their circumference is all the way around. Okay. Circumference is all the way around. How long is that? So if I took a piece of string and I went around my water bottle, and then I took that string out, that's how long the circumference is. Okay, it's wrapped around the circle, however long that is, that's the circumference. It's the length. If it was a rectangle, we call it perimeter. Okay. So that's the idea. That's the circumference. Okay, so the circumference is coming from this pi business, and it's 2 times pi. All right. And I've cut the circle into quarters here. So if the whole circle is 2 pi, then how much is just that? How much is just the top half? If the whole thing is 2 pi, then how much is half? 1/2 of the circumference is 1/2 2 pi is pi. Okay. So if I'm just looking at the top half, how much is that circumference? It's just pi. Okay. So the top half is just pi. Right? Sure. So if that's true, how much is just this? I'll switch colors. How much is just this guy? The whole thing is 2 pi. Then the top part is just pi. Then that quarter, yeah, Michael, it'd be 1/2 pi. Sometimes they call it pi halves. It's just 1/2 of pi. Okay. So that's what we're thinking. It's a very specific circle. It's of radius 1. It's centered at 0, 0. Okay. The circumference is 2 pi because it's a perfect circle. Half of it would be the circumference of pi. The quarter would be 1/2. Okay. All right. What about right? Let's draw it correctly. There's a really special spot I want to get to right here. Right here is halfway between there. Okay. X equals 2 pi if radius equals 1. C equals 2 pi if radius equals 1. Yeah. Okay. So the whole thing is 2 pi. You cut it in half, you get pi. You cut it in half, you get half of pi. You cut that in half, you should get pi over 4. 1/4 pi. That's the idea. All right. This particular spot I'm thinking of is halfway between x and y, equal. Okay. This distance here and this distance here, what I want is them to be equal at this spot. Whatever that location is, that's where I want it to be. I want it to be where it's equal. It's half. I cut that sector in half. Okay. Where is that? Where is that located? So there is some x value and there is some y value right there. And I need to figure out where that is. Okay. What I'm going to do is I'm going to walk you through it. And then once I walk you through it, we will just say that's the truth. Okay. I'll also show you how to find it on a calculator in multiple different ways. But I'm going to walk you through where is that x and y. Right. In fact, there's 3 values in this piece that I want to walk you through. Once you understand what those 3 pieces are, you'll understand the entire circle and maybe the entire subject of trig. So I want to kind of really focus on this piece for a second. Okay. So I need to kind of walk you through a difficult subject for this one because I think you might get something out of it. I think. Okay. So what am I looking at? I'm looking at this triangle right here, right? Let's look right here. I'm gonna rewrite it. That's not so good. I gotta remember where the dead spots are. Okay, so I'm looking at that triangle. I want this point. That's what I want. I know that's radius 1. I drew a right triangle. Okay. So there's some length here. There's some length here. And I want to know what those are. I'm trying to figure out where the location is for X and Y. Where is this on this circle? Now remember, we have x squared plus y squared equals 1. At this point, wherever that point is, this particular point is of equal distance between the y-axis and the x-axis. Okay, it's in the first quadrant. This is quadrant 1 in the dead zone of this TV screen. It's in quadrant 1, so they'll both be positive because they're in quadrant 1, right? Whatever that x value is, it's positive. Whatever that y value is, it's positive. I don't know what the number is, but I know they're positive. Okay, so I know that. I know they're equal distance. Okay, from those ideas, I claim whatever they are, whatever that value is, they have to be the same. For that location, that particular location right there, whatever the value of x and y is, it has to be the same value because they're of equal distance of x and y, they're at some location, and they're stuck on this circle. They're both positive, they have to be the same. So whatever they are, x equals y. It has to. So if that's true, and I believe it is, then we can actually solve for what that value is. So we have x squared plus y squared equals 1. We're on the circle with radius 1. Okay. So I think we have x squared plus x squared equals 1. They're the same. They are the same. Okay. So Michael asks, if radius, only if radius equals 1, when we learn about the unit circle is of radius 1, okay? If it was of radius 2 and we redeveloped trigonometry, it would be slightly different, okay? It would be a different value. Wait, maybe I'm overreaching on what you wrote. You said only if r equals 1. Rules only work for unit circle. What rule? I don't want to overly answer your question. I don't want to answer something that's not there. C equals 2 pi if radius equals 1. That's true all the time. I mean, that's the circumference of a circle. Okay, so if they're at this position, I think they have to be equal, whatever that is. These positions are on the unit circle. X squared plus y squared equals 1. Okay, that means they're the same. So I'm just going to say that we have x squared plus x squared equals 1. They're the same, whatever that value is. Now I can solve for that value. Okay, so I have 2x squared equals 1. Okay. And after going through all this algebra, I know how to solve that. Okay, so that implies that x squared equals 1/2. So what is x? Well, that means that x equals 1 over root 2. I know it's not negative because I know I'm looking for a point in the first quadrant. Okay, I know where I'm looking. So it must be 1 over root 2. That is the value for the x, right? So now we know what that is. Often written as root 2 over 2. Okay, so it's the same value, but usually we write it with a rationalized denominator. I claim they have to be the same value because of that location, very particular location. Where was that location? It was a quarter of the way. So it's in the first quadrant. It's at pi over 4. and that's where it's located. In trig class, we'll call this pi over 4. That's where it's at. These are called radians, and I'll go over that more and more and more. But this is at pi over 4, that location. Okay, so if you believe me, we don't have to go through that proof again, and you don't have to go through it. It's done. Okay, the proof is in the book. The proof is online. It's on YouTube. It's on whatever you want. You can ask your favorite AI, and it'll give you the same answer. It's been well known for a long time. But what else can I say about it? I think I actually know quite a bit more than just that point at this moment. I mean, a circle is pretty symmetrical. I think we could say that. I think it could be said that it is a very symmetrical shape. Okay. So there is a point over here which is roughly the very same. Okay. So over here, there's also that location. But it's in quadrant 2. So it's not going to have the same sign. Okay. This is quadrant 2. And so the x would be negative, but the y would be the very same. This is negative root 2 over 2. This is positive root 2 over 2. Okay. I think there is a spot down here which is the same. Right down here, or you could think over here, it's the same. But it'll have a different sign. This would be negative root 2 over 2. Negative root 2 over 2. And there's another one. It's right here, or you can think it's right there, or you can think it's right here. I mean, it's right there, right? There's another spot which matches up with these. This is at positive root 2, negative root 2 over 2. This is in quadrant 4. So 4 spots. I mean, it's a circle. It's pretty symmetrical. So if we can figure out one, we kind of get 3 others for the same price. Okay, so that's kind of nice. All right, I haven't told you what those angles are yet. I'm going to, but I just wanted to show if you figure out one thing on the circle, you figure out a lot. Okay, because there's so much symmetry going on at once. Okay, so the whole point of this slide right here was to introduce the unit circle, which is what I'm trying to do, and to find the location at pi over 4. Those are the 2 things I'm trying to do right now. By doing that, I also find 3 other points just by changing the sign. Okay, I'm going to go over this all again in a different way, but this is the introduction of it. Okay, once we have these points, we don't have to find them again. They're always there. They're always there. They're already in your calculator. They're already in your homework. They're already on your test. They were before you, they'll be after you. Okay, that is the location at pi over 4 on the unit circle. Okay. All right, I need one more point. I need to walk you through one more point, and then we'll have the whole unit circle. Okay, so I need to walk you through one more. But let's write down at pi over 4, we have root 2 over 2, root 2 over 2, and hopefully I didn't lose anybody at this step, right? You have 1 over root 2, and a lot of times people want to rationalize the denominator. So you have root 2 over 2. Now, I personally don't care if you write 1 over root 2. I've had textbooks write that. It doesn't bother me. But some homework systems get really bothered if you have the square root at the bottom. Anyway, so we have pi over 4, pretty sure. Pretty sure we have it. Okay. Again, I need one